Alright, so we got this crossing Ontario. Apparently the Lake Ontario was crossed 43 times. Men and women have both made the crossing. And then they gave us the distribution. So now we have to, they want us to construct and interpret a 95% confidence interval and then comment on the assumptions and conditions. Alright, so we'll do those two steps. Obviously, we're not going to do panic here, though that's the way we should do it, but that's not what they asked us to do. So our confidence interval is going to be x bar sub 1. So we'll do x bar sub 1 will be the female score. So we'll do 1271.59 minus 1196.75 plus or minus t. We'll figure out what that is in a second. And then we got to do the standard deviation squared over n. So for females it was 22 plus the standard deviation squared over n for males. Okay, so that's what that's going to look like. So what we're going to do is we're going to go to calculate test, and we're going to do 2 SAMP-TINT, and we're going to go to stats, and we're going to put in our statistics. So we got 1271.59, standard deviation 261.111, n is 22. For the males, it's 1196.75, 304.369, and 20 is n, and 95%. We're not going to pull, we'll calculate that out, and it comes out to negative 103.2 to 252.9. Negative 103.2 to 252.9. So what that means is we got to interpret that now, right? So we are 95% confident. Now what went first, the males or females, right? So in this case, we are 95% confident. That the mean time is between 103.2 minutes less than to 252.9 minutes more than the mean time for males. Okay. Then we got to comment on the conditions, right? So the one condition obviously that concerns us is this one right here. The time for males is skewed right. So the fact that it's skewed right is a problem. Okay, so that could be a problem. Okay, now as far as the rest of the conditions, I guess this would be representative. The samples are definitely independent. 20 and 22 is less than 10% of all people that could cross Lake Ontario. But the one condition that does concern us is the shape of the distribution.